Okay, so finishing 4.1, the next part that we needed to talk about was complementary and supplementary. And I think we kind of went over this last time we talked, but we didn't do any of the examples or anything like that afterward. So complementary just means that they add up to be 90 degrees. Since we want to be always talking about radians, that means they add up to pi over 2. And supplementary means they add up to 180 degrees. But again, because we want to talk about those in radians instead of angle or degree measure, that means they add up to be pi. So complementary means they add up to be pi over 2. Supplementary means they add up to be pi. Another key note, they both have to be positive. Okay? So I know that's going to trick you whenever we have it on WebAssign. They both have to be positive. So if I have an angle that's already bigger than 90, it doesn't have a complementary angle because there is no thing that I could add to something over 90 to make it 90 and still be positive. Does that make sense? Okay, cool. So, oh, it's being laggy. Wait for it. Okay. So if they're in degree measure, we're going to want them to add up to be 90 for a complement and 180 for supplement. Remember, they do have to both be positive. And then for in radians, we want this to add up to be pi over 2 or pi for supplementary. So for A and B, the complement and supplement will be in degrees. For C and D, the complement and supplement will be in radians. So for 72, what would I have to add to 72 to get 90 degrees?
18.
How'd you get that?
90 minus 72.
So 90 minus 72 is 18 degrees. That's a positive number, so we could say that the complement is 18 degrees. For the supplement, we can do the same process. So we want them to add up to 180. So we'll do 180 minus 72, which is 108. Cool? Nothing too crazy. Complement adds up to 90 degrees, supplement adds up to 180. So for part B, if we're calculating the complement, if I do 90 minus 148, that gives me a negative answer. So I'll actually compute that for you just so we can have that answer on there. So we can't have negative 58. So we would say none. Okay, so your complement and your supplements have to be positive numbers. Since that's a negative number, it doesn't have a complement. Cool? Okay, and then for our supplement, we're going to do 180 minus 148. So 180 minus 148 is 32 degrees, and that one's a positive number, so that one's okay. Cool? Okay, give me a heart if you're ready for part C. Seven, 12, 13, 14. 15. All right, so for part C and part D, our complement and supplement are going to be in radians this time. So they're going to add up to be pi over 2 or add up to be pi. So we're going to subtract the same way that we did before. So for our complement, we'll do pi over 2 minus 2 pi over 5. If you're not that great with fractions, now is the time to learn fractions. So we need to make a common denominator here, meaning we want our two bottom numbers to be the same. So in this case, we would want them to be 10 because that's the multiple that 2 and 5 have in common. Does that make sense? Okay, so we can multiply this one by 5 over 5, and we can multiply this one by 2 over 2. which gives us 5 pi over 10 minus 4 pi over 10, which is just pi over 10. Nothing too bad. If you're terrible with fractions, you can use the Desmos scientific calculator, and you can type in 1/2 minus 2/5, and then it'll give you the answer of 1/10, and you'll just add the pi back on top. Cool. And then for our supplements, we will do pi minus 2 pi over 5. So same thing as before, we do have to find a common denominator. In this case, that common denominator is 5. So we'll multiply this one by just 1 over 1 so it stays the same. And our other one is going to be by 5 over 5, which gives us 5 pi over 5 minus 2 pi over 5. And then on top, 5 pi minus 2 pi is 3 pi over 5. Okay, since I feel like you guys got enough practice, I want you to try part D. So if you're not that great with fractions, like maybe it's not your strong suit, totally understand, you're one of many people in the world. If that's the case, you can open the Desmos scientific calculator and you can do 1/2 minus 4/5. Whatever your answer is, so long as it's positive, you can put the pi back on top. And then you can do 1 minus 4/5, and then you put pi back on top. So give me those two answers for the complement and the supplement. Give them to me privately in the chat. You can also do it on your handheld calculator, so you can just press alpha y equals to make the fraction. And you can subtract the fractions and then just add pi back on top. For part C, Alexis? I didn't do E yet. I'm confused. C, okay. So the complement, you're doing pi over 2, and the supplement, you're doing pi. So that's, instead of like 90 degrees and 180 degrees, those are their radian angle measures. So 90 degrees is the same as pi over 2, and then 180 degrees is the same as pi. And remember, if it's negative, then you're going to say none. If it's positive, you'll just say what the answer is. Luis, you are correct. Isabella, we can't have negative. Aiden, you are correct. Oh, okay. For which one, Liam? Is that for the complement or the supplement? Okay, then you're right. Diego, you're right. I lost my spot. Natalie, you're right. Israel, those are both right. Diego, double check that one. I have a different answer. Luis, you're right. Isabella, we can't have a negative number, so you would say none instead of the answer. But your other one is right. Isabella, Luna, your answers are right. Diego, that's right. Dwayne, that's right. Anna, Alexis, those are right. Jocelyn, for the first one, that should be negative, which means that there's none. Dwayne, that's right. Liam, that's right. Thank you for specifying. Aiden, that's right. Okay. So I feel like we're hopefully not struggling too much with the fractions with the use of technology wherever we need that use of technology. I didn't get answers from everyone, so feel free to try to beat me to the answer before I get it, because I'm obviously going to write on the work as well. So for the complement, you're doing pi over 2 minus whatever the angle is. So in this case, it'll be pi minus 2. I can't talk. Pi over 2 minus 4 pi over 5. And if we do that, that gives us 10. Wait, just kidding. 5 pi over 2, 5 pi over 10, minus 4 pi, nope, 6 pi. I feel like I should just write the work. I'm doing this wrong. Times 5, that's 5, times 2, 8 pi. Okay, see, this is why you don't do work in your head, which gives us negative 3 pi over 10. So we would say none because we can't have a negative number. So I saw right answers for that one, and then for our supplement, we're subtracting it from pi. So we would do pi minus 4 pi over 5, which is the same as 5 pi over 5 minus 4 pi over 5, which is pi over 5. Cool? So if you're doing these on your homework and you get a negative answer, you're going to put none, or it might say like put D and E, but I think it says to put none. So you'll just write none. Cool? Complements and supplements have to be positive. All right. Our next key concept is now we are talking about arc length. So definitely write that formula down. Also, maybe write this reorganization of the formula. It's the same formula, just reorganized to solve for S. So S is the arc length. The arc length is like a certain piece of the entire circle. So instead of having the entire circle, it's just a piece of it, like the arc. And it's R, which is the radius, and then theta, which is the radian measure. And then give me a thumbs up when you are ready to move on. Got one thumbs up. 2, 3, 4. 5, 6, 7, 8. So again, if you were struggling with the idea of what radians are, it's the length of the arc divided by the radius. So for any circle, the length, like the outside circumference, but not the whole thing, just part of it, divided by the radius. So a few more people give me a thumbs up when you were ready to move on. I think I only got about 12 responses. 13, 14, 15, 16. 18, wait, 7, I lost count. Was that 17? I don't know where I was. Was that everyone? Maybe, yeah? Okay, cool. So find the arc length. So again, the formula for the arc length is S equals R theta. I had to write it down because I forget it sometimes too, where R is the radius and theta is the radian measure. So we can almost plug everything in, except that this gives us the degree measure and we need the radian measure. So far, so good. Okay, so we know from the picture that the radius is 4. That piece of information is given to us. However, we need theta to be in radians. So option number 1 is you can multiply it by pi over 180 to change it to radians. Option number 2 is you can go look at the unit circle and tell me what 240 degrees is in radians. Which would you prefer? The mathy way? You got it. So the mathy way, we'll multiply by pi over 180, which gives us 4 pi over 3. So far, so good. Yes, maybe. And then to get your actual arc length, you'll multiply r times theta. So in this case, S will be 4 times 4 pi over 3, which is 16 pi over 3. Not too bad, right? Bless you. Do you want to practice one? Okay. Pretend that's a circle. Pretend that's a straight line. Pretend that's also a straight line. Let's go with 60 degrees and a radius of 5. So theta is 60 degrees and the radius is 5. So feel free to privately message me the answer in the chat when you get it. In case you can't see, the theta is 60 degrees, but you're going to need to change it to radians. Oh my God. You are correct, Elise. You're correct, Alexis. You're right, Stephanie. You're right, Quade. Quade, that was to everyone. Now everyone knows the answer because I said they're right.
I realized that after I sent it, and then you said it was right before I could say anything about it.
I do that like in almost every class where I'm like, dang it, I shouldn't have said anything yet. Well, everyone should have the right answer now, but try not to cheat. I think you guys can do it on your own. You're probably already at the answer anyways. For anyone that might be struggling, can we get some help with what 60 degrees is in radians? You don't want to help each other? Oh,
Pi
go
over
ahead.
3.
Pi over 3. So 60 degrees is the same thing as pi over 3, so you'll multiply 5 times pi over 3. 1, 2, 3, 4, 5, 6. Okay, do you want me to go over it since we already know the answer? Okay, so in this case, our radius was 5 and our theta in radians is pi over 3. So our arc length is 5 times pi over 3, which is just 5 pi over 3. Cool? Not too bad? Okay, give me a ta-da when you're ready to move on. Since it looks like some of you are still writing, I don't want to rush you. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I lost count. Is that everyone? I think that was everyone. All right, I'm scrolling. So our next two key concepts are the linear speed and the angular speed. S is your arc length, so S is referring to the formula that we learned earlier, and T is referring to time. And then for your theta, that's referring to radians, or the angle measure, but in radians. And I'm going to write those down too so that I can refer to them later. L equals, we're proud of you too. S over T and A equals theta over. I still don't understand that word. It doesn't even sound like a positive word. Like it just, I don't know, it doesn't. Right? It just sounds like, to me, like if I heard somebody say that to me, I would think that they're calling me like stupid or something. Like that's
Sounds
how
like
it
poggers, like you're cussing or something.
Yeah, like, doesn't sound positive. So I was trying to upload your guys' scores while you were waiting, but it's not even letting me view the document because it's like, nope, you're on Zoom, you can't do anything else. So that's fine, no worries. So I feel like you guys probably won't struggle with this because this is just using that formula. So again, remember that S is that same formula as earlier. So R theta. So another way you could write this is R theta over T. That might help you visualize it in a different way. Cool, cool. A couple people still writing, so I'll wait just a second. All right, looks like we're all done. So linear speed and angular speed. I wrote that second formula because I plugged in what the arcvic is, so the R theta over T. So I do want you to notice that this top one is R theta over T and the angular speed is just theta over T. So if you have the angular speed and you divide it by, or if you multiply it by the radius, it'll give you the linear speed, just in case you want that information. So first one, the second hand of a clock is 10.2 centimeters long. That's going to be the radius. As shown, find the linear speed of the tip of the second hand. Cool? Are we okay? Hopefully, maybe. Okay. So what is our, what do we need? S over T? L equals S over T. So how could you figure out what the angle is in this case? Not everyone at once. Could you make an educated guess? And if so, can you explain where you got your estimate from? If that, I don't know if that's what I mean. So it looks like half of you are trying to figure it out. So go ahead and try to figure it out. No worries. I'll give you some time. So we need to figure out what our theta is in this case, or we need to figure out what our arc length is in this case. I think I missed a part of this question, unless we're just talking about the whole clock. Maybe. We could be talking about the whole clock. So 4.1. Let's make sure. All right, that works. So did you guys figure it out? No? Okay. So in this case, we have S over T. S is the arc length. Since we're talking about the whole entire clock, we're just finding the circumference of the whole entire clock, or the radian measure of the whole clock. Does that make sense? Yes, no, maybe. So we would say that our theta is just going to be 2 pi because it's the whole circle. Still good? So if you forget that on the unit circle, it starts at 0 and it goes all the way to 2 pi. And then we can multiply that. So our arc length is theta times r. So we'll multiply that by the radius to get the arc length, which is the same as the circumference in this case. So we'll do 10.2 times 2 pi. And we can actually, we'll leave it like decimals, how the book has it. So 10.2 times 2 is 20. Let me write 20.4 pi. Still good. How long does it take for that second hand to go all the way around?
60 seconds.
You're right. Or a minute, yeah. 60 seconds or a minute. Do you want to use seconds or do you want to use minutes?
Minute.
Minutes? The book says it in seconds, but I mean, it didn't specify which unit that we wanted. So we'll do both. How about that? So if we want the linear speed in seconds, we would do 20.4 pi times or divided by 60, because that would be in seconds. If we wanted it in minutes, it's going to be a lot easier to calculate because we're just dividing it by 1 minute. So let's go to our handy dandy calculator. Okay. Oh, I could just cheat. 20.4 pi divided by 60. So in seconds, it would be 1.07 centimeters per second. And in minutes, it would be 64 centimeters. Centimeters per minute. How do you feel about it? So I saw, where is it? Isabella. I couldn't find the chat. There's a bunch of things afterwards. Did you figure out along the way what we were trying to figure out? Okay. I didn't see that until just now, so I guess it was a little bit late. So it'll tell you whether to find the linear speed or the angular speed, so you'll know which formula to use, and it'll give you most of the information. Like in this case,
Saw that all we had was 10.2, and you were like, "Did you find it yet?" And I was like,
yeah, I was confused too because I was like, they didn't give us what the angle is, but then I was like, oh, maybe they're talking about the whole clock. And then when I looked at the book, they were talking about the whole clock. So I think the ones on your homework though, I think they give you like theta is whatever, not this big. But can you guess what the next example is? I bet you can't even guess.
angular speed.
You could guess, okay. So this one has angular speed and linear speed, so we'll be doing both. Cool? You want me to write the formulas down? Because I have them memorized from earlier. Just kidding, they're not memorized. The linear speed is S over T, or R theta over T, and the angular speed is theta over T. Okay, so if I have a diameter of 15 inches, what is my radius?
$7.5.
How'd you get that?
Dividing half the diameter.
Okay, so just remember that we always divide it in half. So far, so good. Okay, so because this says that the car makes 9.3 revolutions per second, right? That means it goes all the way around each second. Yeah, I'll pause for a second. So anytime you have the diameter, you always want to divide by 2 to get your radius. Really? Stop freezing. Oh, my computer froze. Oh no. Don't freeze. Okay, it's good. All right, can I continue? All right, cool. I didn't want to rush you. So we have that it's 9.3 revolutions per second. So how long is the outside of the tire? Because that's what we need to figure out, because we need to figure out the arc length. So how could you find that out? Try something. Try something and tell me what you think.
The theta by doing the arc measure over the radius.
So the choking myself. So by the arc measure, you mean the arc measure that we're trying to find, right? So you're saying we should use the formula S equal, where is it? R theta.
No, it's theta is equal to S over R.
So rearranging that formula, the other
Yeah.
one that they gave us first, right? So in this case, we're actually wanting to multiply our revolutions per second times the entire circle, which is 2 pi. Does that make sense? Yes? No? Maybe? Sort? Okay. So we're actually going to say that our theta in this case is going to be, or not theta, sorry, our S in this case. Wait, no, it is our theta. I'm confusing myself. Why did you guys let me do this? Is 9.3 times the entire circle, which is 2 pi. Sorry, long day. And if we multiply those together, we get 18.6 pi. And then we can plug that into our question. Notice that in our question, we already were given the time, right? So this is already radians per second. So we've actually already found our angular speed. 13.6 radians per second. Does that make sense? Okay. And then I think the one in the book is, or the one in your homework is like that as well, where it already gives you the revolutions per whatever. So you're just going to be multiplying it by 2 pi, which is the entire circle. And then for our second part, oh my God, I can't talk today. Our second part, we are finding the linear speed. So we're using that S over T. In this case, they already gave us, or we already found what our theta is. So do you remember this part, the second part of the formula? We already found what that is because they gave that to us in the question before that. We just found that in angular speed. So we're just going to be taking our, I can't think. We're going to be multiplying our radius times theta over t, which is the same thing as our radius times our angular speed. Does that make sense? Okay, so up here we said that the angular speed is theta over t. We already have theta over t, which is 18.6 pi. We're just going to multiply it by our radius, which was 7.5. So our linear speed is 7.5 times 18.6 pi. which comes out to approximately 438.25 inches per second. Second. There we go. So it's currently 225. There are no other examples in this lesson, but I do want you guys to work on your homework because I feel like there might be some questions, especially on the linear and angular speed. But I know a lot of you are kind of done already. So when we come back on, what's today? Wednesday? Friday? We'll go over 4.2, which should be fine. Cool? Cool, cool.